Okay, Unit 1, Quadratic Functions, Day 2. Basically, the goals are the same. We're going to do some review from yesterday and just extend on what we learned about the three forms of quadratic functions. So here's just a little chart to summarize what we talked about yesterday, the three forms of quadratic functions. So factored form, if you remember, was y equals a times x minus r1 times x minus r2. Things we can easily see from this form, we can get our x-intercepts, which is r1, 0, and r2, 0, whatever those values are. We can use our a value to determine whether it opens up or down, and we can calculate the vertex. Okay, so the second form we looked at, or one of the other forms we looked at, was vertex form. Vertex form is y equals a times x minus h squared plus k. From this form, we can get our vertex, which is hk from the form. And again, we can use that a value to determine up or down. Standard form is y equals ax squared plus bx plus c. So from this form, we can get our y-intercept easily, which is 0c. And actually, this is the form where we calculate the vertex. X equals the opposite of b over 2a. And then calculate y. Up here, when you calculate the vertex, you're using the x value halfway between the intercepts. And we'll do an example to show you that again. All right, so for this one, we have standard form. Here is standard form ax squared plus bx plus c. A is equal to 1, coefficient of x squared. B is equal to 2, and c is equal to negative 3. So from this form, we can get the y-intercept, and that's 0c. So that would be 0, negative 3. We can use our a value to tell us it opens up. And we can calculate our vertex. X equals the opposite of b over 2a, which is negative 2 over 2 times 1, which is 2, which is negative 1. Y is equal to, plugging in negative 1 into the equation, we get negative 1 squared plus 2 times negative 1 minus 3, which is 1 minus 2 minus 3, which is negative 1 minus 3, which is negative 4. So my vertex is at negative 1, negative 4. Okay, so we're going to graph this using 5 points. So I already have 2 points. I have my y-intercept and I have my vertex. So my y-intercept is at, I can put my vertex on there first. That's probably the best thing. -1, -4, 1, 2, 3, 4. My vertex or my y-intercept is at 0, -3. So if you remember, symmetry is about the vertex. So I'm going to have another point. If I go left 1 and up 1, then I can use my pattern because a is equal to 1. So from here, I can go over 2 and up 1, 2, 3, 4. So remember, we're going up 4 because of the quadratic. So if I go x equals 2 to the right, 2 squared is equal to 4. So then I'm going left 2 and up 4 as well. So give the coordinates of the vertex. Well, I've already done that. And this is called a minimum because it's the lowest point on the graph. The equation of the line of symmetry, called the axis of symmetry, basically that is an imaginary line that goes through the vertex. So it says equation because vertical lines are in the form x equals. So since my vertex is at -1, -4, my line of symmetry, or my AOS, axis of symmetry, is x equals -1. So it's simply the x coordinate of the vertex. We looked at that just a little bit yesterday when we looked at the factored form of a quadratic function. So we'll look at that again here in a minute as well. So I believe we've covered all the pieces of the puzzle on that problem. The only other thing is we could have made a table of values. Using these 5 points. So if I want you to do that on a quiz or a homework assignment, I'll actually give you a table so you know you need to do that, or I'll tell you to find a table of values. All right, so this second one is in vertex form. Okay, so remember vertex form is y equals a times x minus h squared plus k. So the vertex is hk. So since this is subtraction right here and this is subtraction, that's minus a +3. So my vertex is 3. And since that's a plus k, my vertex is at 3, 1. Since a is equal to +1, then this is going to be a minimum because it opens up. All right. So that is basically the easiest thing you can see from vertex form is the vertex and the a value. So I'm going to go ahead and put my vertex on here, 3, 1. Then I know it opens up. So I can graph using my 5 points simply by using that pattern that I've talked about a few times. So from my vertex, I can go over 1, up 1, over 1, up 1. Okay, so remember I'm doing that because of pattern in A is equal to 1. So then to find the second points, I'm going to go over 2 and up 1, 2, 3, 4. And in this case, I'm going to go over up 1, 2, 3, 4. So here I get my quadratic. If I needed to put my 5 ordered pairs in a table, I would have 5 nice points right here. Save a little bit of time. I'll do 5 points on the next example just to show you what I'm talking about. Okay, so I did this part using my red graph right there. I've already done the coordinates of the vertex and whether it's a maximum or a minimum. And my line of symmetry goes through the vertex. So my AOS is simply the x coordinate of the vertex, x equals 3. And it says again, equation of a line of symmetry, so it has to be a x equals. Okay, so I'm a little bit picky about forms, and I'll emphasize that when I actually have you in class. Okay, so for this next one, I'll go ahead and do the table for this one since this video's shorter than the rest of them. Okay, so this is factored form. Or again, it's called intercept form. So remember that's x minus r1, x minus r2. Okay, so factored form or intercept form. Okay, so from here I can get my x-intercepts. Oh, I forgot to put my a there. X-intercepts. R1 is equal to -2, 0. I'll show you where that comes from. And +4, 0. Okay, so this equation right here, since that's addition, before it was changed, it was x minus -2 and x minus 4. So right here, you can see that R2 is equal to a +4 and R1 is equal to a -2. That's where those intercepts come from. And I know, again, a is equal to 1. I haven't changed that on you for any of the examples yet. Okay, so I can put my intercepts in here at -2, 0, and 4, 0. 1, 2, 3, 4. So here's where that axis of symmetry comes into play, because halfway between -2 and +4 is 1. So my axis of symmetry has to fall halfway between those intercepts. So my AOS is at x equals 1. So in order to find my vertex, I simply plug in x equals 1 into the given function. So I would have y equals 1 plus 2 times 1 minus 4, which is y equals 3 times -3. So y equals -9. So my vertex is at 1, -9. Okay, so that's going to be right there. Okay, so you can see that this parabola has to open up because my x-intercepts are above that vertex. Okay, so then I can find a couple more points on this graph simply by going over 1, up 1, to the left 1, up 1. And you can prove to yourself that these intercepts are actually on the graph. Because if I go over 1, 2, 3, well, 3 squared is equal to 9. So I would go up to 9 and I end up at my x-intercepts. Same thing this way, 3 to the left and up 9, because 3 squared is equal to 9. So then I could finish my graph. I could actually find a couple more points on here if I wanted to. From my vertex, I could go over 2 and up 1, 2, 3, 4. And I would have another point there. And if I went left 2 and up 1, 2, 3, 4, I would have another point there. So I found 7 points for you on that one. Okay, so if I was going to do a table of values, I would put my vertex in the middle, 1, negative 9. And then I would go up to 2. And that 2 is going to be sitting down at negative 8. And if I go backwards this way, I know my y-intercept is at 0, negative 8. I go back to negative 1, and I'm sitting right here at 1, 2, 3, 4, 5, negative 5. And here I'm at 3, negative 5. And I could put those points in my chart as well. Another way to find the y-intercept, if you wanted to calculate it, for your y-intercept, x is always equal to 0. So if you plug that into the original problem, I get y equals 0 plus 2 times 0 minus 4, which is 2 times negative 4, which is negative 8, which just so happens to be the y-intercept right here, 0, negative 8. Okay, so I've given the coordinates of the vertex right here. And maximum or minimum. So again, this is a minimum. And the equation of the line of symmetry is right here. So I didn't organize myself very well. But hopefully you followed what I was doing there. All right, so one last little piece. I'm going to give you some ordered pairs, and we're going to create a function. So the thing we have to do is figure out which form is the most useful. Okay, so if you look at the pattern right here, this point right here has to be my vertex. So my vertex is at negative 2, negative 1. So vertex form, that's my H and that's my K. So if you look at what's going on here, I've got negative 2, negative 1. Well, if I go over to negative 1, 0, I'm here. And if I go left 1, I'm at negative 3. And so on and so on. So I know A has to equal 1 because of my pattern. So if I go 1, 2, 3 over to this point, well, 3 squared is 9. Negative 1 plus 9 is 8. Okay, so I'm going to use vertex form here. Since I know my vertex, y equals a times x minus h squared plus k. So y equals, I know this is equal to 1. I've got x minus negative 2 squared plus negative 1. So a better form is y equals, I don't need this 1 here, x plus 2 squared minus 1. Okay, so later on we will look at how to change from one form to another. I also could have got factor form from this. or intercept form. So right here, -3, 0, and -1, 0 are my intercepts. So I've got -3, 0, and -1, 0. So this is R1, and this is R2. And again, because of the pattern, A is equal to 1. So factored form, y equals A times x minus R1 times x minus R2. So y equals 1, A is equal to 1. So x minus -3 is x plus 3. And x minus -1 is x plus 1. So I could also have written factored form pretty easily. All right, so you have a exercise set 2 that you need to work on. Pay attention to the Google Doc or the calendar that I send out. That way you'll know when these exercise sets are due, when I'll let you work on them in class. But you can always go ahead and get started on them, and then if I give you time in class to ask questions, you'll have plenty of time to do that.